All right, guys, welcome to another episode of CUDA Education. Um, First of all, if you guys want to be able to follow along with the application and the scripts and just using Vulkan, you need to get tutorial number 1 and tutorial number 13. Tutorial number 1 is um, installing the Vulkan API on a Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is installing all of these examples. If you want to be able to run the ray tracing stuff, you need to make sure that your GPU is ray tracing capable. For NVIDIA, that's RTX and above. That's tutorial number 1 and tutorial number 13. All right. I have the links down below for you guys to get to them. All right, so today I intend it to be a quick one. I simply want to discuss passing variables between shaders, right? It's a very specific video today. So we have our application that's dealing with shadows, and basically we have a light rotating around a scene, and with light you have shadows, and we need to calculate the shadows, and the shadows basically appear here, right? With sort of familiar territory. We've done this in several videos now. Okay, so but just to refresh your memory, we have a primary ray from the camera coming in. The primary ray hits basically traverses the scene, and on every point visible in the scene from the primary ray where we get a hit, we have to do a shadow test to see if it's, so like right here, to see if it's a shadow or not a shadow. So what happens is that upon the initial hit, a second ray is generated from the hit point to the light source, and an intersection test is done to see, does anything come between the light source and the hit point. If something comes between it, then that point is shaded. Hence, we get our shadow. Because all of these points right here, are marked as shadowed because there is something between the hit point and the light source, right? So a primary ray comes in from the camera, which is what we're seeing here. This is our vision. And then upon hitting something, a second ray is generated from that hit point to the light source to test if it's a shadowed area or if it's a lit area. So this is a lit area, this is a lit area, and the shadow moves along with it. You might see a little granularity in terms of this getting darker and lighter, but just understand that the light source is moving. So it's not necessarily a shadow thing, it's just that the light source is moving, right? So that's just that. But this right here is definitely shadowed, and this is like, non-shadowed, right? Or what have you. Okay, so the problem though is that when we have our primary ray and our secondary ray, or a shadow ray, so we have our primary ray and our shadow ray, we need a way to communicate variables between the two rays. So information needs to be passed from the primary ray to the secondary, to the shadow ray, right? Or shared, right? Or you need to update a variable that's kind of accessible or visible between the two shaders, right? And this is where the topic of our conversation today, this is where we have these two guys come in, RayPayloadInEXT and RayPayloadEXT. All right, so let us just get some. So we have our ray tracing shadows application, we have the shaders, the GLSL shaders, and we have our 4 shaders, right? We already know what miss is. RayGen is the primary rays traversing the scene from the camera. The hit shader is basically when you hit an object, and then the shadow shader, shadow mist shader is do we shade, do we keep a point shaded, or do we make it lit, right? So we have a regular mist shader, which is a sky model, and then our shadow mist shader, which is it a shadow, or is it a lit point, right? So let's start with RayGen. So we generate rays into a scene from the camera. We do have this variable hit value. And as far as I could tell, all it is how dark or light is the shadow, right? I don't want to get into the details of the algorithm quite yet, but I'm just dealing bite size with the RayPayloadEXT discussion, right? So we have this variable called hit value, and it's RayPayloadEXT, right? Which is a thing that is used in the Vulkan API. And in this case, for the RayGen, RayPayloadEXT for hit value is a variable that's originated from the RayGen shader. So it's originated from the RayGen shader, and then you're broadcasting it out, okay? It is at location 0. All right, so think of RayPayloadEXT as a radio station, right? You're at the radio station, and you have broadcast satellites, broadcast towers that's broadcasting out information, right? So in this case, RayPayloadEXT is broadcasting out hit value. Now this hit value is accessible by the hit shader, right? So you see now we have RayPayloadInEXT, RayPayloadInEXT. So we have to highlight this in ext. What this in means is that this RayPayloadInEXT means is that now the hit shader is receiving the hit value. Okay, so the hit shader is receiving the hit value. So we have our RayGen. And then we have our hit value here, right? So we're receiving hit value, and then we use the hit value down here. Basically, let's see. We use it here, and we use it here, right? I mean, as far as I could tell for this part, it's how dark is the how dark is the shadow. All right, so we have our ray generation. We broadcast out hit value, and it's being received by the closest hit shader, right? And we do some calculations with it. I don't really want to get into the weeds of exactly what we're doing, but basically we use that hit value. We receive it, and we have access to that value, and we could modify the value and all that stuff, right? So we receive it here, and then we do some other stuff with it, okay? But at least it's accessible for location 0 here, okay? Continuing with the conversation, closest hit also originates a variable, okay? So closest hit also originates a variable. The reason is that we now have to deal with the actual shadow decision, okay? So is the variable, is the point at which we had the intersection, is it shadowed or is it not shadowed, right? Is it lit or is it not lit, right? So we originate another variable at location 2 called shadowed, okay? So we now in the closest hit shader, we originate this shadowed variable. Notice that it's again RayPayloadEXT, not RayPayloadInEXT, just RayPayloadEXT. RayPayloadEXT means now we're being a radio station again, and we're broadcasting another variable called shadowed at location 2. Okay, so we have this shadowed variable at location 2, and now we're broadcasting that to make it available to other shaders, right? So we do some processing with the variable, but we also make it um, available for other shaders. Now notice that by default, the by default everything is shadowed. So our scene, just from the jump, everything is shadowed, and then from the shadow shader we decide, okay, this point is actually not shadowed, so it's lit. Okay, I know it's a kind of a tongue twister, and I don't know why it was decided to do it this way, but by default everything is shadowed because we have shadowed equals true. And then we trace shadow ray and offset indices to match shadow hit miss shader group indices. So let me not get in the weeds with this quite yet, but we have originated this shadowed variable. It's at location 2, and we use RayPayloadEXT as the type or the command that we use to broadcast this variable to make it available to other shaders. So just as we broadcast now, there is a shader that actually receives this variable and does stuff with it, and the shader that receives the variable and does stuff with it is the shadow miss shader, right? Or the miss shadow shader, however you want to say it. The shadow miss shader, miss shadow shader. This is not the regular miss shader with the sky model and the blue background. This is the shadow miss, right? So as you can see here, layout location 2, ray payload in ext bowl shadowed. Okay, so now the shadow shader is receiving the shadow shader is receiving the shadowed variable, and then it's manipulating it to a different value, right? So it's basically turning off the shadow because it's saying, hey, based on my shadow situation and calculation and everything, this point is supposed to be lit, so we're gonna turn off the shadowing, right? And that's basically it. So we have, I'll repeat again, we have hit value originated in the RayGen shader. It's originated with Ray Payload EXT, right? Because it's broadcasting out like a radio station. So Ray Payload EXT hit value. This hit value is received by the closest hit shader, as we can see here, Ray Payload in EXT. Obviously the locations have to match, so we have location 0 here, we have location 0 here, and then it's in EXT, which means that we are now receiving hit value. Continuing with the same conversation, closest hit also originates its own variable and broadcasts out. So it originates a variable called shadowed at location 2, and it uses RayPayloadEXT again as the command or the type to actually make this shadowed variable accessible to all, right? And that shadowed variable is received by the miss shadow or the shadow miss shader using Ray Payload in EXT at location 2. So notice again, location 2, right? Consistent location. Similar with hit value, we have location 0, we have location 0, right? Notice, of course, that the shadow miss shader, it has no use for the hit value, so we don't receive in the hit value variable because we're not using that. Okay. That's pretty much the conversation here. Also notice this number 2 I want to make sure I do it. So this location 2 is also being used right here. So we have location 2, right? Does it give me any information? No, but this location 2 is also being referenced here, okay? So this is it's basically that variable, right? Um, and this is trace ray, shadow ray, and offset indices to match shadow hit miss shader group indices. So this is where the shadow ray is being generated. Okay, so we use this trace ray ext to generate the shadow ray. I'm gonna do another video on this thing specifically, so I don't want to dive too much into it. But this is where the second ray from the hit point to the light source is being generated, right? And we have a bunch of flags: terminate on first hit, opaque, skip closest hit shader. We want to reference the miss shader, not the shadow shader, not the miss shader. We want to reference the shadow shader, not the miss shader. All that stuff. We have our light vector, all that stuff, right? Because of course we have to figure out what the position is of the light when we're, the shadow is from the hit point, the shadow ray is from the hit point to the light source, right? So we need to pass that in. But we pass in the location of the shadowed variable also in this trace ray ext command, which I'll get into in another video. Okay, but we notice that we have our shadowed we have our shadowed variable, and then the shadow mesh shader does what it needs to do. Now I just want to do a quick thing. I'm going to disable, I did this previously before, but we'll do it again. I'm going to disable the shadow miss shader. I'm going to disable the shadow miss shader, right? So basically the shadow miss shader doesn't do anything, right? Remember I said that the everything is set to shadowed by default, right? So everything is set to shadowed by default, right? So if we disable the shadow miss shader, then basically that the shadow miss shader has no ability to turn off the shadowed default scene, right? And we'll see this in a second, right? So when we run our script now, we see that everything is shaded, right? Regardless of whatever is going on with the light source. Remember I said that the little hues that we see on the shoulder of the object is not really the shadow. Well, you could definitely see it here. The light source is still moving, so we do get slight modifications of the darkness and lightness of the object depending on where the light source is. But as far as the shadowing portion of the conversation, we have no shadowing behavior, right? We have no shadowing behavior. This is just because the light source is moving, but this is not the shadowing behavior that we're talking about, right? So this is all possible because we have first of all, we're passing in variables and we're sharing variables and stuff. So let's put it back to what it originally was, and we're going to recompile our shaders, right? And we're going to get back our original application, right? So now I've re-enabled the shadow miss shader, and we should, get back to what we originally saw, okay? So let's just do that real quick, and then we will. I wanna actually proceed with another quick experiment. All right. So then when we run it again now, the shadow miss shader now has the ability to turn off shadowing. So as we could see, now we have dynamicism in our application. We're able to see the lit regions, and we're able to see where the shadow is. Notice that this on the shoulders of the object, we could see that it still gets lighter and darker, but that's just because of the rotation of the light source. That is not anything to do with the shadowing. This little piece right here, you're gonna see this little piece right here. Um, this has to do with shadowing. You see that? That has to do with shadowing, right? But as far as just the general, you know, and then of course we have our shadow down here. So we get that, right? It's not anything. Now let's kind of just do a fun game. Let's flip the script. So we're gonna do false. We're gonna default everything to not shaded, and we're gonna just disable, let's just disable our shadow mesh shader, and we're gonna default the scene to not shadowed, right? So when we, oh, first I gotta compile again, of course, guys, you know, I gotta compile our shaders. Just while we're waiting on that, just know, guys, that shaders are sort of external sort of compute file things, and we have to compile these shaders into the spare V format, which is a proprietary format from the Kronos group that basically boils everything down to a lower level granular language. The reason they have this spare V language is because they want to make GPU behavior consistent across all vendors and all models and everything. So there's no equivocation about what is going on with the instructions from vendor to vendor, from situationship to situationship. It's all consistent because they're all reading the spare V language, and it's supposed to be consistent across all situations, right? So anyway, now we have our everything is lit by default. So everything is lit by default, and now everything is lit by default, right? And everything is lit by default. Everything is lit by default. We do still have our light source rotating, so on the object itself, we get, you know, the hues of the brightness of the object itself. But notice that there's no shadow being cast anywhere. No shadow being cast, right? There's no shadow being cast. No shadow being cast. No shadow being cast. All right? So no shadow being cast, okay? So we don't have any shadow being cast. Okay, so no shadow being cast, that's fine. All right, so then now let us go. We're gonna enable this, but then we're gonna say true. All right, so let us recompile our shaders, and let's see what we get. All right. So now we get something a little bit funny. Ha. So now the script is flipped. So now we get the shadow is actually the lit portion. Okay. So the shadow is now the lit portion, right? So this is like a nice computer graphics effect. If you guys were wondering where exactly the shadows were being shown, and you were a little bit confused because you were whatever, you prefer to flip the script, this is what we get in pretty cool, huh? Pretty cool. And there we have it, guys. So there you go. That's computer graphics. Now, for all you creatives, right? For all you creatives, for all you guys that want to work at DreamWorks and Pixar and you know, all these big game studios and stuff like that, animation places, simulation, all you scientists, data visualization and all that stuff, This is the things we are talking about. This is the things we are talking about, right? So the thing with Vulkan is that you basically have, you have control over everything, right? You have, it's a lot of code, and yes, it takes time to get through everything, but the thing about it is that you are able to, do exactly what you want, how you want it, and do it as efficiently as possible because you have control over everything, right? So this is what we have right here. Okay, so let us put everything back to normal. Right, I gotta make sure my application is back to normal so I could start fresh again. Um, and that's pretty much it. That's pretty much all I wanted to cover for today. Um, so this this Ray payload in EXT and Ray payload EXT stuff is pretty cool. It's pretty cool. Does a mist shader? Okay, the mist shader takes in it takes in the hit value also. So the closest hit and the mist shader takes in the hit value, but the shadow mist shader doesn't take in the hit value, right? But yeah, it's pretty cool stuff, guys. I mean, let me just run my application, make sure we're back to normal. All right, we're back to normal, guys. We're back to normal. So um, I'll do another video continuing the conversation, but now we know what Ray Payload in EXT and Ray Payload EXT is and how it works. Yeah. And then we also briefly discussed this trace ray ext, which basically does the shadow ray casting, right? So it basically generates a shadow ray from the hit point, from the initial hit point, from the primary ray to the light source, right? So think of these variables as being associated with, it's a payload for the ray. It's a ray payload. So you're flying from one place to another place on an airplane, and you have hand luggage, you have personal item, you have checked in baggage, and you're not just flying your physical self to the place, you're carrying luggage, baggage, personal items, carry-on items. Make sure you put your stuff in the overhead bin, and know that in the overhead bin things may shift during flight, all that good stuff. Okay, it's the same concept here. We're flying in rays, and with those rays we have baggage and luggage associated with it, and therefore we have these things. All right, guys, again, tutorial number 1 and tutorial number 13. Tutorial number 1, install the Vulkan API. Tutorial number 13, install the examples. I assume you have a Windows machine, ray tracing capable GPU. If the GPU isn't ray tracing capable, you could still run every other example. So even if you don't have a ray tracing capable GPU, as long as you have a Vulkan capable GPU, you'll be able to run every other example except for the ray tracing stuff, right? For NVIDIA, it's the RTX cards and later and above. I don't know what time what point in the future you will be watching this video, but basically you will have ray tracing capabilities, assuming it's a modern GPU from NVIDIA. There's also Intel and AMD, but I can't vouch for those vendors. Yeah, guys, good video today. Thank you for watching. I don't have anything else to really talk about today. All right, goodbye.